Okay, the first example I'm going to do is w minus 1 is less than negative 4. This is a subtraction inequality. I'm going to use the addition property of equality to add 1 to both sides. Negative 1 and positive 1 create a 0. They wipe each other out. And I get left with w is less than negative 4 plus 1 is negative 3. Okay, I'm going to box out my answer. I need 3 intervals to show my graph. I'm going to put my solution to the inequality in the middle, negative 3, a value to the left, which is negative 2. I'm sorry, it's negative 4, not negative 2. Negative 4, and negative 2 goes to the right. Okay, my sign here, my symbol, is just less than. There's no equal to sign. So I am going to have an open circle. And my arrow, I can look at that point there, is to the left. So my arrow is going to go to the left. Okay, make sure you make that line nice and dark so I can really see it when I'm checking your work. And I'm going to now check it with this value for w, which is negative 4. So my check is on the right-hand side. I write my original problem, w minus 1 is less than negative 4. I'm going to substitute negative 4 in, which we got from our graph. So negative 4 is less than, negative 4 minus 1 is less than negative 4. I'm going to go ahead and simplify my left-hand side. Negative 4 minus 1 is negative 5. And negative 5 is less than negative 4. That checks out, it's correct. Moving on to example 2. I have x minus 3 is greater than or equal to negative 2. Again, a subtraction inequality. We're going to use the addition property of equality to solve by adding 3 to both sides. And we're doing this to isolate our variable. Negative 3 and positive 3 are additive inverses. They cancel each other out. I get x is greater than or equal to negative 2 plus 3 is positive 1. I'm going to box out my answer. 3 intervals evenly spaced out. And in the middle, I'm going to have my solution to the inequality, which is 1. 1 value less is 0. And 1 value greater than is 2. Make sure that when you have differences between the negative intervals and the positive intervals, some of you are getting these confused in class, make sure that your numbers are actually in order. Okay, so I'm going to have a closed circle because it's greater than. It's greater than or equal to. The equal to makes it closed. And my point here is on the right-hand side, so my arrow is going to go towards the right. Okay, I'm going to use this value right here for x is equal to 2 to substitute in for my check to see if my arrow and everything works out correctly. X minus 3 is greater than or equal to negative 2 is my original equation. Substitute 2 in for x. 2 minus 3 is greater than or equal to negative 2. 2 minus 3 is negative 1. And negative 1 is greater than or equal to negative 2. That checks out. Okay, remember that we have 2 integers here, positive 2 and negative 3. Big minus small, keep the sign of the tall. 3 minus 2 is 1. The sign of the taller number was negative. Moving on to example 3. H minus 2 is less than or equal to negative 5. Now, keep in mind, if you are okay with these questions, you can fast forward or rewind if you need to go back to review. I'm just trying to get it to focus here for you all. There we go. All right, much better. Okay, again, I'm going to add 2 to both sides. Additive inverses, they cancel each other out. I get h is less than or equal to negative 5 plus 2, negative 3. 3 intervals, evenly spaced out. Our solution to the inequality in the middle, a value less than -3 is -4. And I have -2. Closed circle because it's it's less than or equal to. The equal to, we fill it in. And our point is to the left, so our arrow is going to go towards the left. Okay, made the arrow nice and dark. I'm going to use -4 to check. I'm going to substitute. So h -2 is less than or equal to -5. -4 -2 is less than or equal to -5. -6 is less than or equal to -5, which is true. It checks out. Okay, our next example is example 4, and this time our variable is on the right-hand side, so watch what we're going to have to do. We still have a subtraction inequality. We have to add 6 to both sides to isolate our variable. Okay, additive inverses cancel each other out. -1 plus 6 is +5, which is less than g. But our variable is on the right. We have to flip-flop it. So g, now notice that our point is next to the 5, so it's going to be next to the 5 here. This is our answer, and that's what we're going to graph. 5 goes in the middle, 6, 4. Okay, notice that these are reversed than this because these are negative and these are positive. We have an open circle because there's no equal to sign, and our point is to the right. Our arrow is going to go to the right. And I'm going to check. And my check, I'm going to substitute g for 6. So I have -1 is less than g minus 6. -1 is less than 6 minus 6. -1 is less than 0, which is true. Okay, number 5. Same situation as example 4. Up here, we added 6 to both sides. Now we're going to add 3 to both sides for example 5. And we are doing that to isolate the variable. -3, +3 are additive inverses. They cancel each other out. They create a 0. -9 plus 3 is -6, is less than k. We have to flip-flop to get our variable on the left. k, my point is next to the -6. So my point is going to be next to the -6 there. 3 intervals evenly spaced out. -6, -7, -5. Open circle because there's no equal to sign, and my point goes to the right. Okay, I'm going to check, and I'm going to substitute -5 in for k. I get -9 is less than k minus 3. -9 is less than -5 minus 3. -9 is less than -8, which is true. It checks out. Okay. Clip number 3 will have some more examples, and you're going to want to watch it because those are some of the examples that some of you were getting confused on in class. So make sure you watch clip 3. 2-5, solving inequalities containing integers, clip 3. See you in a minute.